press record. We'll record this session.
Okay.
You're going to have to be able to verbalize the questions for me.
Okay.
What kind of stuff are we doing? I don't know if it's hard to verbalize or not.
So right now we are working on, hold on, I'm trying to see the title.
You can find one problem, I'll be able to figure it out. Just give me one problem
We're
today.
working on probability statistics and data.
Okay?
Well, problem one, can I show it on the video?
No, just verbalize it to me and I'll write it and you'll be able to see it.
Okay. It says exercises 3 and 4 complete the two-way table.
Yeah, these are tough to verbalize.
Yeah.
Can you take a picture of it and send it to my email address? That's the next best way of you getting me problems. We can work this out. I'm going to put my email address up on here. And I want you to take a picture of the material that you're looking at and send it to my email address, and then I will pull it up on my screen and we'll both be looking at it.
Okay.
Send it to that email address.
Okay.
Are you using an iPhone?
Huh?
Are you using an iPhone or a Samsung?
My iPhone.
Make sure you send it as a large image, as a file attachment and as a large image, not a small image.
Okay.
We just went through this with a student right before our session. They sent it as a small image. When you blow it up, you can't read it. Resolution isn't good enough. But if you send it as a large image, it comes in crystal clear.
Okay.
Tell me when you got it in there so I can take this page down and check my emails.
Okay, hold on. Do you think we can talk through the GoToMeeting app, or are we still going to do it?
Don't know. I'm not sure. I've never had anybody do it by phone. I'm not sure that it will matter. In other words, probably the audio will be through the GoToMeeting, yeah, which might take care of some of the connection problems. The problem is if you're using your phone and you have poor reception at your dad's house, I got to think that's going to present a problem, but we'll see.
Okay.
Tell me when it's been sent.
Does it say is it C-O-W-A-N?
Yes. A-N, yes.
Okay.
It's David Cowan,
Okay.
1949 at gmail.com.
All right.
And if your dad should get home like around 5, maybe you can switch over to his computer, which already has GoToMeeting on it, because we did this once before, and just enter the meeting again through his computer. And that'll work out much better. Just make sure his computer is not set to automatically reboot at 5:15 or whatever.
Yeah, sorry, I don't know why the iPad's not working now.
Well, you got to make sure it's charged up. In other words, sometimes if you let it completely drain, I don't know, I don't have an iPad, so I'm not sure, but I would think that you'd be able to plug the charger in and it would have power, but maybe not. Best way is to make sure it's fully charged before our session, if you're going to use it for our session. Okay, have you sent this picture yet?
Yeah.
Okay, let me see if I got it. Not yet. Make sure there's only one picture attached at a time. Here we go.
I sent,
Nope, I just got it. I just got it. There it is.
I sent you though.
Well, it works kind of like this. If you send one picture, it takes like 10 seconds to send it. If you send 2 pictures, it takes 30 seconds. If you send 4 pictures, it's liable to take 3 minutes.
Yeah.
So there's a definite relationship. Which one do you want to start with? The one on my right or the one on my left?
Since I'm not in the meeting anymore. Great.
Here, let me look. Yeah, it disconnected you somehow.
Probably because I started to...
Possibly. It might be tough. Why don't you've got GoToMeeting on that iPhone. Go ahead and re-enter the same meeting ID number, pull up the app, and come back into the meeting.
What was the digit again? I'm so sorry.
344 278 885.
885. Okay. All right.
I wondered whether that was going to present any problems where when you tried to take a picture and send it to me, whether that was going to mess with your GoToMeeting.
344 278 885.
Yes.
Right?
Yep.
Well, it's not letting me click the join button anymore.
Tell me the number you're putting in.
It's 344 278 885.
Yep. That's the same number. And you've pulled up the GoToMeeting app.
Well, now it does. Now it's letting me join, I think.
Okay.
I don't know. I don't.
Ooh, I just got an incoming call. Wonder what that is. Wonder if that was you.
Not me. I'm not quite sure what's happening right now.
Well, we got to get that GoToMeeting app working again on your phone.
Yeah. Here, let me. Hold on. I'm going to try one thing. 344 278 885.
Actually, there you go. Now you're in. Your connection might be fine because you're using the Wi-Fi now.
Yeah.
In your house. You're not using your phone connection. You're using the Wi-Fi, so you should have a good solid connection. All right, so you can see my screen?
Yeah.
Which picture should I open? The one on the right or the one on the left?
The one on the left.
Okay. Which problem are we doing?
So there's 1 and 2 I've already done because they're just definitions. So 3 and 4 are the tables.
Okay. So, these tables, can you see where I'm pointing my cursor?
Yeah.
What has to go in this block right here? What number? If 38 plus that number totals 50,
12.
what? Okay.
12.
Fill in 12 into that block.
Okay.
Now what has to go in the block above it if that's 12?
So 6.
Okay. Now the block to the left, what has to go there?
4.
Okay. And now the block above that, what has to go there?
34.
And
34.
And then finally, the block on the far right,
40.
you just filled in the table.
Okay.
Now, number 4, similar thing. Let's start with that block right there, because we can figure out what that should be.
Okay, 3.
Okay, the block below it is what?
59.
59, is that what you said?
Yeah.
Okay. This block here under the no, what is that?
48.
Okay, the block to its right.
98.
Okay, and then finally 98 plus 10, what's the total on the lower right?
108.
Right, and that's the way you're going to do all of these. In other words, the rows add to the total, the columns add to the total, and the very right-hand column adds to the right-hand lower right total.
Yeah.
So you just have to have a few pieces of information to be able to figure out all of it. If they didn't give you this 6, we'd be dead. In other words, we wouldn't be able to do it.
Yeah.
So they have to give you enough information that you can do it.
We did some of those in class.
Okay, number 5, do we want to do?
Yeah.
Okay, let me read it.
Do you want me to read it?
No, I'm reading it. I'm just trying to figure out how to do it. Okay, so let's talk about a two-way table. Let me open my drawing tablet here. And let me go down, and I'm going to make my table. Now, the thing about these two-way tables is this is always total, and this is always total at the bottom.
Yeah. Yeah.
So, and everything in between is going to be the data. Let's see, we've got 171, and which you put on top and which you put on the rows, I don't think matters a whole lot. We'll call that males, that females, and we'll call this washed hands and did not wash hands. Okay, you with me?
Yeah.
Hold on, I don't need this line. Can you see this good enough on your phone?
Yeah.
Okay. So what they tell us, we had 171 males, so I can fill in that. We got 180 females, I can fill in that. We got 132 males that wash their hands. And we got 151 females that wash their hands. You guys are so much clean. You guys are so much cleaner than us. Okay, so what goes in the males that did not wash their hands?
So it would be 171 minus 132, which is
39.
Yeah.
Okay. What goes in the female that did not wash their hands?
29.
Okay. Now we got everything. What's the total number that washed their hands? Just add the rows. Add the rows together. 283.
Okay.
Whenever we're doing an online session, you want to make sure you have a calculator in front of you.
Okay.
Okay? What's the total that did not wash their hands?
Hold on, I got it on my calculator.
Okay.
68.
Okay. Now what's this right-hand bottom, which is the total of these two or these two? Should be the same number in either case.
351.
And notice that that's the sum of the column, and it's also the sum of the row.
Yes.
It's kind of like, a little like Sudoku, I don't know. Not really, but the one thing is the totals have to be totals. In other words, this has to be the total. This has to be the total males. This has to be the total females. This has to be the total males and females. This has to be the total that washed their hands. This is the total that did not wash their hands. So we've got everything we need. All right. Let's go on. What's the next one to do? Is it 10? What happened? What happened to 6 through 9?
I don't know. They just made this course back for everyone.
But 10 is the next problem, right?
Yeah.
Okay. It looks like all of these are going to be relatively the same. In other words, they're all going to be modeling the information in these tables.
Right.
Okay, so let's do number 10.
Okay.
Let me have a look at it.
Got my iPad started up.
Okay, it's actually going pretty good using your phone. You can, if you want, you can try using the iPad and logging out from your phone and then logging back in with your iPad. Might give you a little bigger monitor to look at, but I don't know, is the monitor size a problem?
No, it shouldn't be.
Okay.
Just for
On
future,
these,
right?
yeah, for future, you always want as big a monitor as you can have in front of you, because part of the problem is seeing all of the information. Okay, but for these kind of problems, we're generally talking about tables that are 3 by 3. In other words, we're going to break the table up into 2 by 2, and then we're going to add a totals column and a totals row.
Okay.
Okay, and I'm going to label those totals. That's always total there. It's always total up here.
Okay.
Now, what we have here is we have 49 people receiving a flu vaccine before the flu season. 63 people did not receive it. Of those who received, got flu. Okay, so across the top, let's start with flu vaccine, no flu vaccine. With me? Across the rows, of those who received the flu vaccine, you either got the flu or you didn't get the flu. Did not get the flu. You can label these as complicated as you need to in order to figure out what they mean. Okay? And whether I use these in the tops of the columns or the row labels doesn't really matter. I could do it either way. Okay? I chose to put, whether you got the flu vaccine or you didn't, I chose to put that at the top of each column, just because that's where they start. So 49 people received the flu vaccine. That means that's 49, right? Label the rest of this table. And refer to it as the square to the right of that or above it.
Okay, but then it said 63 did not receive it, so that's next to it.
Okay.
All right.
And then keep going to the far right. What's the total going to be here?
Total is 112.
Okay. Now, of those who received the flu vaccine, 16 got the flu. So where does the 16 go?
That have received the vaccine, is that what?
Of those who received the flu vaccine, 16 got the flu. Where does the 16 go? In which square?
The upper, middle at the top.
Upper left. That's the upper left.
Okay.
right? In other words, 16 people got the flu vaccine and they still got the flu. So of those who did not receive the vaccine, 17 got the flu. Where does the 17 go?
To the right of that.
Okay, now that's enough information. We can figure out every other square. What's the square below the 16 equal?
33.
What's the square below the 17 equal?
46.
What's the total of got flus equal?
33.
And what's the total of did not get the flu?
79.
And 33 plus 79 better equal 112, or we've made a mistake somewhere in our addition. Okay? Now, I could have done it like this. Let me just, so that you won't be confused by anything I said. I could have done it where I labeled this, they got the flu vaccine, or they didn't get the flu vaccine, and then they got the flu, or they did not get the flu. And I could label a table. In other words, there's still 16 people that got the vaccine and got the flu, and there's 33 people who got the vaccine and did not get the flu. So you notice how I can do it either way? I can still fill out this whole table. This is still going to be 112. This is now going to be 49. This will be 63, and so forth and so on. So the table will look different. But what I'm trying to point out is it doesn't matter which you make the head of your columns and what you name your rows. You can do either or. Okay?
All right.
Now, conditional relative frequencies based on the flu vaccine. Now, let me erase the second. That was just for illustrative purposes to let you know you could do it either way. In other words, you don't want to get hung up on what to name your columns and what to name your rows. Okay? Now I'm going to do a conditional table. And notice that from the first table that I got, I really can't tell percentages very well. In other words, does it make sense to get the flu vaccine or not? 16 people got the vaccine and they still got the flu. So what would be more useful to me is if I had the percentages. What percentage, remember that's got flu and did not get flu, and that's got the vaccine, no vaccine. Now, what percentage of the people who got the flu got the vaccine? How do you come up with that?
15 divided by 112.
Good. What's that number? Good. That's correct. What is that decimal? What is 16 divided by 112? In other words, I don't want to put a ratio in there. I want to put a decimal.
0.142.
We'll round it off to 2 decimal places. And I never put the leading 0. I don't know why they teach that, to be honest. Not necessary. It's just an extra digit that you have to write every time. No need for it. 0.14 means exactly the same as 0.14. And the problem is it takes up space. And we have a limited amount of space to do this. So now figure out the relative percentage of the people that no flu vaccine and got the flu.
0.15.
Point what?
1.5.
0.15, okay. Do the same thing for the 33. Give me a percentage.
0.29.
Same thing for the 46.
And then that's 0.41.
Now notice, if I add my conditional frequencies, I get 0.29 there. I get 0.70 there. I get 0.43 there. I get 0.56 there. And everything adds up to 99. It should add up to 100. The only reason it's not adding up to 100 is because you round it off. By rounding off, we dropped enough information that it no longer adds up to 1. But now we have some very interesting data that we can interpret. In other words, 14% of the people who got the flu vaccine got the flu, whereas 29% of the people who got the flu vaccine did not get the flu. So clearly, you should get the flu vaccine based on that alone. But now, for the people who no vaccine, 15% of them got the flu, but 41% did not. So, do we really need the flu vaccine? This is actually telling us that 41% of the people that did not get the vaccine did not get the flu. That's the highest percentage of anybody. If I was making my decision based on this table, I would not get the vaccine because there's a 41% probability that I will not get the flu.
Yeah.
And 43% of the people in the study got the flu vaccine. 56% did not. 29% got the flu. 70% did not. So you can see that there's a lot more meaning in the conditional relative frequencies. It gives you information that you can interpret and act upon. If your decision was, do I get this flu vaccine or not, this table would be very useful, especially if it's based on thousands of people. In other words, if it's only based on 50 people, you could take it or leave it. But statistics are always more relevant if the larger the sample size. That's one of the key things about statistics. Is the bigger the sample size, the more valid the conclusions. Now, like I said, if this was only based on, say, 50 people, well, my conclusion is I'm not going to take the vaccine and I'm not going to get the flu. 41% likelihood. But if this was based on 5,000 people, I bet you we wouldn't be looking at this data. We'd be looking at data that suggested we should get the flu vaccine. In other words, it makes sense that I know that scientists all, would agree that you should get the flu vaccine. It does reduce your chances of getting the flu, but not according to this table, it doesn't. It actually increases it. Well, not really. 14% of the people who got the vaccine got the flu. 15% that did not get the vaccine got the flu. So that really doesn't tell you much there. But you can go down to the bottom row. 56% of the people that did not get the vaccine, and 43% of the people got the vaccine. We just don't know how many people there were. And how many people does matter because it increases the accuracy of your conclusions. Statistics, that's always the case. I can flip a coin 3 times and come up with 3 heads. Not that hard to do. It's going to happen 1 out of every 8 times. But if I flip a coin 10,000 times, I'm not necessarily going to come up with 5,000 heads and 5,000 tails, but I'm not going to come up with 10,000 heads. In other words, it'll be more balanced. The more samples in your database, the better. All right, let's do the next one. Problem solving?
Yeah.
Is that the next one we should do? Number 18?
Yeah, well, 12 is just the percentage part.
Yeah, what 12 said was use the table from number 10 to make a two-way table that shows the conditional relative frequencies. Well, what they mean by conditional relative frequencies is you take the number and divide it by the total.
Right.
That's why we took 16 divided by 112, and that told us that 14% of the people involved in the study got the vaccine and still got the flu. So that's meaningful. That's more meaningful than the number 16. The number 16 doesn't tell us a whole lot in terms of interpreting the data. But the conditional relative frequencies mean a lot. We can figure out a whole bunch from this. I know that 29% of the people got the flu, 70% did not, and so forth and so on. So for number 18, let me read it first. How many groups of people are in group 1?
12.
We've got 12 that exceeded expectations, but we've got 4 more that met expectations.
Your screen went away, you didn't need to do that.
Okay.
Because I can see the yellow sheet, and then I see like your screensaver on the right side.
Hold on a minute. I think what you mean is this went away, right?
Yeah, there you go.
Okay. Yeah, I made it go away just so I could read the problem. But here's what we want to do. We want to come up with a conditional relative frequency. She's going to offer one of these groups a prize. And it's not going to be based on how many people exceeded expectations. It's going to be based on the percentage of the total people that exceeded expectations. So what's the total people in group 1? 16? Here, hold on, let me, I'm going to do it like she's got it. We got exceed expectations, and we got meet expectations. We got group 1, group 2, group 3. The one thing I know is the total in group 1 is 16. How many people are in group 2?
12.
13. When you see a line through, that means the 5th one. So we got 5, 5, and 3. That's 13 in group 2. How many in group 3?
14.
15. Count by 5s. We got 5 there, we got 5 more over here, and then we got 5 individual bars. So that's 15. Okay? Now, the number that exceeded expectations was 12. That met expectations was 4. In group 2, we have 8 and 5. And in group 3, we have 9 and 6. Now, if she was awarding the prize based on just absolute numbers, she would give it to group 1 because they had 12 that exceeded expectations. But I suspect that what they really want here is the highest conditional relative frequency. So let's redraw our table and put frequencies down there rather than absolute numbers.
Okay.
And then we'll choose the highest frequency gets the prize. So group,
all of it is 48, right?
well, are you dividing it by 16 or by 29?
I got 29 for the total.
Well, hold on a second here. I'm not positive. What percentage of group 1 exceeded expectations? How do you come up with that number?
What's the total overall?
Be 12 divided by 16. So 3/4 of group 1 exceeded expectations.
Okay.
Quarter of them just met expectations.
Okay.
Okay. Group 2, in other words, compare 8 with 13, not the total of the total.
Okay.
So what's 8 divided by 13?
0.61.
And what's 5 divided by 13?
0.38.
Okay. And then go down to the bottom row in group 3. What percentage exceeded expectations?
Group 9 was 0.69.
That's 9 divided by 15. Okay, and this has got to be 0.31.
I didn't do 15.
Well, it should be 9 divided by 15.
Yeah, I did 13.
In other words, you have to compare each group differently because they all have different numbers of people in them. In other words, group 1 had 16 people, group 2 had 13. So had group 2 actually gotten 12 people that exceeded expectations, they should get the prize. They have the higher percentage. But in the problem that she gave us, the highest percentage is that one right there. Group 1 gets the prize based on the fact that 75% of their members exceeded expectations. In other words, we're not, in this case, we're not going to compare this number with the total. There's a total of 44 people in all 3 groups. In other words, I could write 44 right there. That percentage isn't as valuable to my way of thinking. She doesn't really explain in the problem how she wants you to do it. But if I was the teacher, I would award the prize to the group that had the highest percentage of people in it that exceeded expectations. That's group 1. Next highest would be group 3. Now, in this particular problem, the absolute numbers are the same as in other words, there's number 1, there's number 2, which is unfortunate. You would think that she would come up with a question where the percentages showed you something different than the absolute numbers. That'd be a better problem.
Okay.
And I'm not even sure what she means here. It doesn't say. It doesn't say she's going to award it to the people that had the highest percentage. Just says she's going to award it to the group that had the highest number, whether the groups met or exceed expectations. Well, 12 people exceeded it, so I guess you award it to group 1. If you based it on percentages, 75% of that group exceeded it. So you still award it to number 1. But that's not always going to be the case. It wouldn't have to be like that. Let's say the numbers were 11 here, 1 there. Now, group 2 has the higher percentage. 11 divided by 12 is a higher percentage than 12 divided by 16. So I would award the prize here to group 2, even though they didn't have as many people exceed it as group 1 did, but a higher percentage of the group did. And like I said, I don't know what she means here. She didn't explain it on the problem well enough to know exactly what criterion she's using. Is she using absolute number of people, or is she using percentage? That's based on the 2 previous problems. Notice that this problem was based on, number 10 was based on absolute number of people, but number 12 was based on percentages.
Yeah.
Well, number 18, she doesn't specify which one she wants to use. So, only way I can do it is both ways. And notice there was a slight difference. In other words, when we did number 12, we had our percentage divided by the total number of people altogether. Whereas in this problem, I didn't do it that way. I divided 12 by 16. Because all I'm trying to do is figure out which is the best group. Well, the best group is the group that should, I would say, have the highest percentage of their group exceed expectations. That's group 1. It's not based on the number 12, it's based on this 0.75 down here. Okay? All right, what else do we got? We got anything else on this page, or?
We just have 3 problems on the page 116.
On what?
The next page, we have 3 problems.
Oh, and you sent me the next page, didn't you?
Yeah.
Let me open it up here.
But we'll probably have time to do 1.
Okay. Let's see, is that the right page? I think it is. We started with the left page, right? Yeah, we only got a few minutes here. This looks like you might have sent it as a small attachment, small file, because that's what happens. That's what, yeah, because what happens when you send it as a small file, I can't ever read it by the time I blow it up. If you send it as a large file or a large image, excuse me, then it comes in with much higher resolution.
Okay, let's all right. Large. Should have just sent.
Okay. Tell me when your phone says sent. And we'll see whether you get kicked off of GoToMeeting this time. Okay, I got the file. You're still in GoToMeeting. So that in itself doesn't look like it kicks you out of the meeting.
No.
Okay, hold on. Let me get everything up here so we can read that. See how crystal clear that is?
Yeah.
Okay. So let's look at their question here. Okay. 20A. What does the number 120 represent? Yep. Parents that said no. Okay. What's 1336 represent?
The total of parents and coaches that said yes.
The total yeses. Yeah, between the parents and the coaches, the total number that said yes. That's 1,336.
Okay.
What's the 1501 represent?
The total of all responses.
The total of all responses. That means there were 1,501 people who responded either yes or no, who were parents or coaches.
Okay.
And notice that there are 1,000 parents, 501 coaches, so the total people that responded were 1,501.
Yeah.
All right. Look at number 23, Venn diagrams. Venn diagrams are fun. You just have to look at them right. Okay? So, first of all, do you understand the Venn diagram?
Yes.
Okay, what does 57 represent?
Number of dog owners.
Dog owners only.
Yeah.
What's the 25 represent?
Cat owners only.
What's the 36 represent?
Both dog and cat.
What's the 92 represent?
Neither.
Okay, so you got 4 categories. Usually when you have 4 categories, a Venn diagram is perfect because you've got some overlap between the 2 categories. In other words, some people have a dog and a cat. You got some that just own a dog. That 57 is not the total in that circle. It's the total not included in the combined either. Okay, so now let's answer their questions. What is the probability that a randomly selected person does not own either pet? Well, hold on a minute. Let's figure out how many owners we have. We have 92 that don't own any. We've got 57 plus 36 dog owners, right?
Yeah,
So,
I think at the top of 23 it said make a table, right?
you don't have to make a table. Oh, I see. To construct a two-way table. Okay. Yeah, we can do that. I didn't see that, but we'll do it.
That's okay.
No,
I
no.
still don't really understand how to do that because I struggled with that class today.
Well, the explanation, making a table might help. Let's see if I can make a table real quickly here. Got our totals going around the outside. So these are cat owners, these are dog owners, and there's actually a third category. There's cat and dog owners. So there's 25 cat owners.
Would there be another column?
Would there be a what?
Another, like, no animal column?
Yeah, there would be. That's why the Venn diagram is actually a better thing than a table.
Right.
Trying to figure out how to make a table. The columns could be cats and dogs. I think you'd need 3 columns because you got 25 cat owners only. You got 57 only dog owners, and you got 36 that own both. So if you total those up, it tells you how many people are in the survey. Those the sum of those 3 numbers. And they're distinct. There is exactly 25 cat owners. Oh, and then there's a 4th column, none. And that's 92. So if you total those 4 numbers up, you get how many people are in this?
Which is 210.
Okay. So what's the probability that a randomly selected person does not own either? So you take 92 and divide it by 210. Is that what you came up with for a total? 210?
Yeah.
So
0.43.
okay. So neither is 0.43. What's the probability that a randomly selected person owns a dog? Who owns a dog also owns a cat.
Okay.
That gets tougher. In other words, I don't know. This is a person who owns a dog that also owns a cat.
So it would be 36 divided by 210.
Not 210. There's a total of this many dog owners. 57 plus 36.
So would it be
36 divided by 93.
okay?
That's the number of people who own both a cat and a dog divided by the number of dog owners. Well, the number of dog owners is 57 plus 36.
That's 0.38.
And, no, that's the only two questions. But I'm not sure exactly how to make this table.
Yeah.
It's usually, you usually don't have both. In these kind of problems where you have like 4 possibilities, you usually either have a Venn diagram or you have a table. It's rare that you would have both.
Yeah.
And I'm not sure how to take this Venn diagram and turn it into a table. Venn diagrams can come in all kinds of flavors. In other words, it doesn't have to be just 4 possibilities. You can have a Venn diagram where you have people taking French, you have people taking Spanish, and then you have people taking German. And some people, that's French, that's Spanish, that's German, and you have some people taking both French and German. And you have some people taking German and Spanish. Maybe you even have some people taking all 3. In other words, there might be an overlap between all 3 circles. But
Yeah.
anyway, I gotta go, so we'll have to end it there.
Okay, thank you.
Now,
Sorry.
yeah, next Thursday, you'll be back at your mother's house, right?
Right, but I have the iPad all worked out now, but
Okay, so there shouldn't be any problem anymore doing it. And you've got the apps both on your phone and the iPad and your dad's computer. So if next week you're going to do it from your mom's house using her iPad or using her computer?
iPad, but I could use the computer too.
Yeah, if you use your mom's computer, you're going to have to download that software again. You're going to have to go to Join, go to Meeting.
Yeah.
But if you use your iPad, you've already got the app on there. Okay, so we can go from there.
But every time I have to get the code from you, right?
Yes. Now, usually what I do is I just text you the meeting ID number. I don't usually call. In other words, once we've done it once or twice, you've got all the information. You just need a meeting ID number. That's it. You've got all the programs you need. You just have to open them up, put in the meeting ID number. So next Thursday, I will just text you the 9-digit meeting ID number, and I'll let you take it from there. And if you can't get into the meeting, call me, or I'll call you. But
next time, before the session, I'll send the papers too.
Yes, that's always a good idea. In other words, be fully prepared so that we can spend the entire hour working on stuff.
Yeah, well, we finished everything but that one problem, so.
Yeah, no, we covered quite a bit today. I'm impressed that we were actually able to do it on your phone. That's only the second time that I can think of in 8 years where I've gotten somebody to actually have an online session using just their phone.
Yeah. It worked.
Well, good. Okay, Emma, I will meet you in a go-to meeting next Thursday at 4:30.
Okay, thank you.
You're welcome. Bye-bye.